So welcome to those of you here today, and would like to acknowledge and celebrate the First Nations on whose traditional lands we meet, and pay our respects to elders past, present and emerging. I'm here on Jara land today in central Victoria, and it is sunny and cold, and we are waiting for rain, which apparently is in Melbourne, hit Melbourne. So very dry. We've got with us today Rob Atkinson from the OGC, Open Geospatial Consortium, and he'll be presenting mechanisms for using controlled vocabularies in the context of 3D cadastre profiles for the ICSM. That's the Intergovernmental Committee on Survey and Mapping, and for specific jurisdictions, as well as a bit of a discussion on pathways toward the Federation of Vocabularies. So just to let you know, we are recording this, so we will hold questions till the end when we switch off the recording. So I think you're right to go, Rob, when you are.
Okie dokie. I'm going to do a bit of a view of the use of vocabularies from the perspective of the sort of downstream implications of how those vocabularies get used, in particular focused on the concept of profiling existing standards. Often existing standards are fairly generic and they get applied to your own domain by using your own vocabularies. So that's one pattern which is fairly common. But there's also a whole range of other issues which emerge, and partly through the profiling, which I'll unpack, around the issues around sharing vocabularies and understanding where parts of vocabularies are being used. And we have a proposal in for a workshop for the RDA, SciDataCon in Brisbane. And I don't know if we've had any updates on that.
Yes, that's accepted, Rob.
It has been accepted. Well, that's great news.
Very good.
Okay, so fantastic. In that case, well, hopefully this will provide some grist for the mill for thinking in advance of those workshops. That's my goal here. Okay, so I want to quickly walk through the OGC, and not everybody may be fully familiar with it. I'm wearing a couple of hats here. I work half-time for Surround, which is an OGC member, which is a local semantics company, and I have a couple of other gigs as advisors to other groups as well. And one particular project we've done recently, which uses controlled vocabularies in this context, is a 3D Cadastral Survey Data Exchange specification for ICSM, and then thinking further about how do we federate vocabularies. So I'll dive into that. So, oops. I've slightly got myself out of sync here already. So one of the examples around the role of OGC is in Europe, we have this concept called data spaces. And data spaces are the sort of large-scale pan-European infrastructure. It's sort of like the whole informatics strategy. And they've got a fairly sophisticated viewpoint where they've broken the problem down into different pieces, and they have a concept of building blocks. Like everybody else seems to have building blocks these days. The big focus around the European data spaces is data sovereignty, which is making sure people control their data, which is not very vocabulary related. But there's also concepts of trust and interoperability, and they explicitly call out semantic interoperability. So it's one of the places where we're involved in multiple projects that are working with semantics vocabularies in Europe. So it all comes part of a much bigger picture of this sort of single European market, all driven by many, probably hundreds of millions of euros in different research projects and so forth, covering different domains. And there's some links there, which is probably just for if you want to follow up on some of that sort of stuff. And data spaces covering many domains, and And this does immediately raise the issue that there will be overlap between domains but different viewpoints. And so you're obviously going to see the same vocabularies or the same concepts being used in different places, but generally a legacy of managing their vocabularies differently. So there's going to be a whole range of interesting challenges emerging, very much an emerging area. And the AGC is very actively involved in projects and all the green ones. And we're certainly looking at where some of the other ones in red there. So this is just to give you a little bit of a sense of so some of the scope of the ADC. Now, this is a European context. We're an international organization, so we're also working with other environments, but very much at the moment, probably a lot of the most coherent research agendas are probably coming out of the EU. So in terms of the global trends, we observe that this data sovereignty, absolutely, but interoperability and governance and controlled vocabularies is a governance issue. There's the trustworthiness, which again is making sure that you understand things, semantics and AI in terms of the mechanisms for how you handle that semantics, and provenance and traceability, which is again linked into trust. We'll see this in Australia, for example, in the whole food supply chain, where the European well, actually the whole supply chain for food and other things like carbon accounting and that sort of stuff, there will be more and more demands for open standards and traceability in provenance. So a bit of context, but what we observe dealing with all these many stakeholders is some general issues. And one is the concept which people will probably accept, which is that standards are complex. There's too many of them. They're too big. They're too hard to read. They're written, there's too many different flavors of them written in different ways. And the cross-references, the references between these things that might explain how they relate to each other are usually buried deep inside big chunks of text. And it's really hard for people to get an easy read on the application of standards against people's needs. They don't tend to be this one-size-fits-all utopian standard that solves everybody's problems, because everybody's problem is slightly different, and so you end up with many different attempts. And if we start at the other end, there's lots and lots of bits and pieces which may be standardized, but how do you put them together? Which ones are compatible? None of it is really that easy. And the more we get down the track of more different types of systems emerging, like we have more and more big data solutions and AI and more sensors out in the field, and there's citizen science, there's more and more different types of informatic systems becoming more prevalent. It's no longer just a big government agency pushing out some mapping data or something. This is just getting, we're getting exponentially more complicated for the end user to interpret this stuff. And then the other issue is that we have this reality that we have local solutions that exist, and we've got activities everywhere looking at common terminology, and sometimes these local solutions may use or extend common terminology, or maybe map to it, or may predate it, or have ignored it because it was too hard, or weren't even thinking about the problem. No, so the reality is we've got this complex ecosystem of terminology out there, and so terminology in general is a kind of an unsolved problem, or where there are solutions they're not really shared. And one of the corollaries of this is that there's been this concept of the semantic web floating around for probably closer to 30 years than 20 years now, but its application has been very limited. And one of the reasons is that the provisioning of semantics, which means governance, managing of identifiers, worrying about these overlaps, all that stuff is still pretty ad hoc. Now, there are little nodes of excellence like ARDC and British Oceanographic Data Centre and a few places out there, AgriVoc. But generally speaking, if you look at the broad thing, it's all very, very ad hoc. So in that context, I'm now going to break down some thinking about some ways of addressing some of those limitations in the context of a case study. And this case study is the Cadastral Survey Data Exchange problem. So the ICSM went out to the market recently because they had run out of options trying to make the old way of doing things work. They've got multiple jurisdictions. They have this thing called Land XML, which is just a fixed schema that was developed in a slightly ad hoc way. It meets some needs, but its use is very incompatible. Every vendor made its own extensions about how where they put things into it. The end result of this is that there isn't any common software that works for all different jurisdictions. So there's nothing. The E-plan solution for Victoria will not work in New South Wales or New Zealand, etc. Furthermore, it was also limited. There were new requirements for 3D and more interesting types of sensing. I mean, surveyors use theodolites, but no, they also use LiDAR and all sorts of things now, which are perfectly valid ways of observing data that just weren't envisaged when Land XML was built. And there's lots of inconsistencies in the terminology that are used across the different jurisdictions. Often they'll use the same term for slightly different things, or different terms for the same thing in their survey regulations, which control what surveys are supposed to do. So they went out looking for a conceptual model and with a recognition that they would need it to be more modular and more extensible than trying to solve this one-size-fits-all, effectively create a big spreadsheet and hope you get all the columns right. And they've also potentially, they accepted the argument to also to modernize the data exchange format. So instead of an XML, which has its inherent limitations about this inflexibility, to look at more modern data exchange mechanisms. So we'll unpack that. And these are hopefully where there was some practical guidance here. So let's just look at it in terms of specific aspects of the problem and the solutions to those. So the domain itself is quite complex. There's a lot of information of lots of different types that is involved in delivering a survey. And so this is a legal record. All that information, all that metadata, everything that's on there, all sorts of information about, what procedures, error correction, and what geodetic reference marks were used to locate this, and there's a whole bunch of metadata above and beyond just the lines about where where things were surveyed. And every jurisdiction has its own flavor of the regulations and terminology. And of course, these have changed over time as well. So it's variable by jurisdiction, it's variable by domain. So for example, your native title version of Cadastra is going to be different from your mining lease version of Cadastra, is going to be different from your land surveys for your cadastral parcels and land title and that sort of stuff. So there's slight variations there, and there's a lot of different problems, and it's hard to say, well, does my standard meet all these requirements? And if you create a big monolithic standard and then try to solve it all at once, you can just imagine how challenging that's going to be, breaking it down. So the solution to that is a very extensive modularity, which I'll unpack a little bit more later and show you sort of some stuff live as well. But one of the key things we basically introduced is the idea of individually testable components, and the ability to compose those components into the whole, and also to inherit the tests from the individual pieces into the whole. So if I know that, for example, my addresses need to use a particular vocabulary, and then I've got my whole package, I need to inherit the tests that the addresses use the vocabulary. So the ability not to have to repeat all those tests, but just inherit them by composing things, then allows us to have a whole bunch of reusable libraries, which are relatively sophisticated. And from, it's not terribly clear here, but you can see there's a bunch of stuff here in the brown, which is topology. There's a whole bunch of topology rules can be applied to those components, which can be reused. If you just have a very, very big, imagine a massive spreadsheet or a massive data structure, and you have your own interpretation of a topology, and somebody else has their another version, it's very hard to say, well, are those two things the same or not? There's so much complexity there that if I have to read two massive, 2,000-page documents describing all this stuff and try to work out what's common and what's different, it's very, very hard to do. So this explicit modularity and inheritance actually has a huge advantage from that end user perspective in terms of complexity, because you can actually see what's common and what's different. You don't have to interpret and read huge amounts of detail. So anyway, the next problem is this issue I mentioned before about how flexible and expressive your model is. And that's kind of where, in the old days with XML or relational databases or spreadsheets, whatever it is, you get a bunch of slots and you basically put some content in that. And if they weren't perfectly designed for the slots you need or the content types you needed, you end up with a whole square peg in a round hole, and things get abused. And that's why no two versions of LandXML were the same. And so future-proofing is a critical thing. Okay, so you can see vocabularies is starting to be put in context here a little bit, because what do these things mean, these slots mean, and what goes in the content? Well, ultimately, if you want to standardize this stuff, okay, well, how flexible, how expressive, my schema isn't going to be expressive for everything. My vocabularies are going to have to do more of the work if I'm going to standardize something expressive. There's another big advantage of this modular stuff is that each individual sub-data model pieces can be tested in many, many different applications. And it allows you to say, well, actually, I don't have to think too hard about getting that bit right. I can just reuse a standard. I can do further, faster, better with standards if I don't have to eat them all in one bite. So if those standards are not inflexible, if they're reasonably flexible, and you've got a mechanism for using that flexibility, they can be combined and we can solve the problem. Another big part of this is the opportunity, I mentioned modernization of JSON and JSON LD. So JSON linked data is a way of annotating a JSON schema, and it's basically non-invasive because you can basically specify, this the context applies to this data structure. You don't have to interleave it all. There is a version of JSON LD where you say all the JSON itself has everything interleaved in it, and it's pretty ugly, and frankly, no one is really using it in that flavor. It's just an RDF serialization, but using fixed schemas and annotating them with a context document. So for example, in this case, you could say that, well, no, what does eats mean? Well, it means this URL unambiguously states where the specific definition that we use, and that URL can be resolvable to get information. You can hit a vocabulary service to actually get the definition. And one of the beauties of JSON, of course, is that you can add things in, you can change the order, all that sort of stuff. It's kind of open for that. You can restrict it if you really want to, but generally speaking, if I wanted to add another attribute, I can actually create another context, and I can actually reference the first context if I need to. We can go into the details a bit later. But basically, JSON LD allows us to do something we couldn't do with XML. We can be flexible. It also allows us to annotate what the individual pieces mean. And we can effectively start binding schemas to vocabularies, which is a great enabler for another next generation of implementation. But we still have this issue that we have simple structures which are quite generic and lots of flexibility, that's great. But your community may be familiar with the concepts but use a different term. There may be many ways of doing things. And the other solution we basically have in terms of this concept of creating profiles of these generic things is to use SHACL, the shapes constraint language. I mean, there are other possibilities as well. Once you have JSON-LD, we can treat it as think of RDF. Every object has an identifier, which means we can have rules about those identifiers. And SHACL is a language that is unambiguous about what those rules are, and it's executable. We can actually execute a test. Does this conform to that profile or not? So instead of reading 2,000 pages of document to try to work out if your data is conformed or what your software has to do, the combination of JSON, JSON-LD, and SHACL actually allows us to test. And in combination with the unit testing of small pieces, this becomes extremely powerful. Next part of the pattern is this issue of profiling, and where the vocabularies comes in. So hopefully everybody starts to say, well, okay, maybe this guy's not completely irrelevant. So I just wanted to sort of go through the sort of the high-level architecture which relates to the governance domains. So in the bottom left-hand, we've got the Cadastral Survey Dataset Model, which is jurisdiction independent. For ICSM, we may say, well, the addresses part of that is going to be constrained to be using an ICSM standard address. The ICSM profile basically will say, well, here's the link to the ICSM, the shared vocabularies that we all agree on, and then each local profile can have its specific vocabularies. And these are bound by JSON-LD context. And the profile description actually allows us to find all the pieces and execute the testing. So these are the mechanisms which we use, and they're all standard mechanisms. The profile vocabulary is something Nick Carr and I wrote as a W3C activity out of the Data Exchange Working Group. JSON-LD is another standard. Vocabularies, we use SCOS. SHACL, which is the way we do things, is another standard. The SHACL rules reference the data typing, which I'll touch base on a little bit later. So the Cadastral Survey Dataset says you must have a survey mark. You must have a type of survey mark described. And then ICSM says, well, actually, these are the types of survey mark. This concept is also a survey mark. So the vocabulary typing allows the SHACL rules say, okay, is it the right type of terminology you put into this place? If it is, then A, it's valid because it's now I've been able to find the vocabulary term. I've been able to check it's the right type. I've been able to check it's the right type for my particular jurisdiction. And now all of a sudden we've got everything we need just by combining available standards. So this then leads to the concept of, well, how do I manage all those pieces, the complexity of those moving parts? And that's basically where we have the concept of building blocks. And the building blocks allow us to have fairly simple SHACL rules, for example, to validate vocabularies, but we can also have more complex SHACL rules for structures to say, for example, a survey, the parcel must be composed of survey vectors, which are joined between 2 points, and each point must have observations meeting some criteria. You can have this complicated logical rules about what data must be present that schema validation can't help you with. But then in your profile, you can just inherit that. That's part of your data model. And then your profile simply says, well, and I'm going to use these vocabularies for describing the things in this data model. So the JSON-LD enablement turns out to be really, really tricky. I'm going to unpack that a bit for you because this is the bit you're probably not familiar with. And it's actually the key to be able to use vocabularies in data exchange specifications. And I will dive into this and take questions. And this is really, really tricky, but it's now a solved problem, and it allows our profiles to be machine readable, which means it allows our vocabulary references not to be in a table in the bottom of page 38 of a document. It's now a part of our machine readable ecosystem that can actually be executed. And that allows us to do unit testing of all the pieces as we go and combine them. And at this point, I'm going to jump, I won't follow the link, I'll just move this across there. I'm just going to jump to having a look at, well, what does this all look like in practice? And again, this stuff's live on the ICSM, as you can see in here, the ICSM GitHub, and I will share the the slides as well. So if we just go to, jump to the top of this. This is our building block. Okay, it has a logical identifier which allows us to reference this thing when it's being combined with other things, regardless of where it lives in the web. And it has a few different views on it. It has an about view, and the about view, one of the first things it has a dependency view, which is fairly straightforward. It's only dependent on the ICSM profile. But if I do the full view, I can actually look at what's underneath that. So you can sort of see the ICSM profile is based on that. The Cadastral Survey data set is based on survey observations and survey quality and survey features. And there's a provenance chain here. There's observation features here, which is all based on observations and measurements, which is another OGC standard. Most of you will know Simon Cox. So Simon and I were, I originally met Simon and employed him to build observations and measurements. So that's a little bit of history. So this is the standard, which is now, again, it's quite complicated if people are familiar with it. But it's very powerful, but it's quite abstract. And so our ability to reuse this stuff and profile it. So the shackle rules behind observation collections and things like that, they're quite tricky and nasty. Now, you don't want to have to reinvent those wheels, but if you can inherit them, you end up with a powerful solution. So that's just the sort of the structural view. But then each of these building blocks, and this is where the power really comes in, allows unit testing. Each of the jurisdictions we're involved in threw us all the nasty test cases that they could think of that have broken land XML. And we were able to generate examples of test cases for every one of these. Okay, so you can see these rather large bits of JSON here, which are being generated. Often, we generated these from existing formats against the model, but every one of these things is combined into or generated a turtle version of it via the JSON LD version. The JSON LD version, all right, just kill that. The JSON LD version itself is kind of tricky, and that's basically what I'm going to unpack now. So the JSON schema for these things, if I look at the source schema here, it's trivial. In this particular case, it's all of just the ICSM schema. We could add additional things to it if we wish. If I look at the ICSM, it's the 3D cadastre schema plus the constraints to use the address schema. And the building block provides both JSON and YAML versions, which are two slightly different technology views, which are equivalent. We can generate other flavors of the schema if we need to. Building blocks are all designed to be joined together. So the ability to create different versions of these things is part of the tooling. But this is where it gets fun, the semantic uplift. So I'll go to the full one. The full JSON LD binding for that structure is complicated and actually has lots of nested places. So bindings are only scoped within the nested part of the schema. If you've ever tried building JSON LD for anything more than the most trivial schemas, it's a nightmare. The tools are not very supported. I tried, I was optimistic, it was complete failure. And fortunately, I went out and nobody else had been able to do it either. So we ended up with this building block mechanism where we actually solved the problem by doing small pieces, annotating the original schemas, and then walk through the schema structure and rebuild the final context. So if I look at the source stuff, and bear with me, this stuff's all very geeky, but here's the issue. Each of these source contexts, all we're doing here is saying that this particular prefix is matched to these various different vocabularies. These are the WA. These are all the different vocabularies which are provided by the WA, the Western Australia profile. All I had to do was specify those and inherit everything else. So all the rest of that complexity is not my problem for my profiling. Profiling for vocabulary is now very trivial. I literally decide, well, I have two things. I have a shackle rule which says, well, actually, I already have shackle rules. I have a profile which says, here's the vocabularies. You inherit the shackle rules. Those vocabularies will get tested. And the purpose of these little bindings here is so that the examples you'll see in here, I don't have to put a filled URI in, okay? It's possible to do without this prefix. There is a way of doing that, but we decided not to do it because we actually think it's useful to have a clue in here about where this is coming from. It turns out that this is it's a fairly simple text string to manage, not like nasty URIs when you don't know where they're going to live. All the binding of that happens in this one file, which is the vocabulary binding for that. And profiling with vocabularies becomes as simple as that if you do everything else right. And I guess this is the key thrust of the message I really wanted to share here. And the second part of it here is you can see here's all the different shackle rules which inherited from all the different subcomponents. Okay, and Western Australia doesn't even need any specific shackle rules because it's only got some rules about naming conventions for points. But if I go to the shackle rule here, and again, apologies, but some people probably, we can sort of see effectively that the class of the survey condition for anything that has a survey monumented by must be a survey condition code. So you can't just put any old value in there. You have to put a survey condition code in this particular slot where that particular slot is used. So where we have something monumented, then the condition of that monument must use this condition code. So again, it's just a series of things. These are not that complicated. Some of them are a little bit trickier. You don't really want to have to reinvent those wheels. Just go back here. Oops. I'll kill that one. Just go back to the validation link again. And if I look at the observations rules, okay. Oops. No, sorry. That's survey observations. So I look at the observations and measurements rules here. These ones. You'll see some really, really hairy, nasty stuff in there. But it's a standard. All that stuff can be done once and tested and got right by experts. Okay, we don't need to reinvent those wheels. So that's the beauty of a modular standards-based thing. So this combination of modular standards and use of vocabularies becomes extremely powerful. We were able to run 150 odd different test cases through the development process, things which are broken 10 years of land XML. We developed the schema, the JSON LD, the building block mechanisms, the whole validation, all the shackle rules, all these examples. All this was done in about 9 months with 2 people working on it, plus one of my colleagues at ARDC helping with the schema annotation and the JSON LD building stuff. I've been doing data modeling for 30 years, and this was so much more productive and powerful, and I have so much more confidence in the output than anything I've done. And we've got a mechanism for machine-readable profiles of the vocabularies as the icing on the cake. So that's the little case study in terms of the mechanism for how we built it. The next piece is the final piece is the ability to document these things. So we can generate the document from all those moving parts. We can generate one common sort of standardized looking document, which is the specification. And you'll see, again, this is a vocabularies group. One of the things we did is we called out the vocabulary bindings as a summary automatically from all those machine readable artifacts which are being tested, get sucked up into this. So this reads the profile descriptions I mentioned, finds all the relevant pieces, and glues it all together. So there's a summary of all the vocabularies that are being used and where they're being used, because it is really one of the key parts of the profile. And then if we look in, the various beasts in here, look at various different flavors of survey. Okay, so if I click on one of these things here, you can sort of see that down in here we see that the purpose must come from one of these two vocabularies. There's a general purpose on this one. Okay, but if I click on this, we can actually see that there's also an ICSM vocabulary for survey point purpose. So effectively, it could actually be it's actually additive. It's not particularly well described here, but we can inherit from all the individual profiles. So all the layers of profiles can also be pulled together. So we have this modular model, which was the other one of the other things which we supported, is we updated Pylo to support modular models, which it didn't do before. And that's all open source code. And it's all in the RDF lib stuff. And Nick Carr and Cara Wong have been actively working on that, and we're looking at building this into the OGC ontology publication chain as a standard thing. So that's a quick little example of what it looks like in practice. So just to recap, we've got this step change in our ability to do semantic interoperability because of our ability to use JSON LD to link a schema to a semantic model. That allows us to link vocabularies, content rules, and vocabularies and logical rules together as content rules to create profiles which are testable, which then allows us to combine things much more rapidly and securely into more complex applications. So to wrap up and give time for discussion, I just want to give a little roadmap, which is, I think we need to focus on how vocabularies are being used. And we've mentioned the building blocks. We're starting to think about capturing the architecture patterns and think about what standards are needed. We've got data models. That's not a problem. We've got Shackle and OWL and SCOS and so forth. These things do everything we need to do. That's great. What we don't have is standardized APIs for accessing these things. We don't have federation mechanisms. We don't have standardized provenance metadata in terms of understanding where terminology comes from and what's happened to it. Now, the building blocks basically covers many, many different aspects, profiling, blah, blah, and the semantic interoperability. So from the OGC perspective, this is a significant investment in order to try to do standards better, more transparently, and this stuff is built into that, which is kind of what I'm talking about is kind of built into it. We need to start thinking about how it's going to be handled across domains, and we can sort of see that now we have metadata, commonality as well as differences. We have schema mappings, we have common APIs, we have common vocabularies, we have crosswalks between vocabularies. All these things need further standardization to understand what the actual different architectural patterns are. And then this sort of gets us into, okay, we start sharing stuff. Okay, how do we do it? Well, one way we do it is we publish what the relationship between things are. Okay, so we can federate by effectively creating alignment matches between them. Another way we could do it is we could say, hey, I'm interested in your domain, but these are the bits I'm interested in, and I'll suck it down and I'll put it in my system, and I may or may not refer to where I got it from. The provenance metadata. Okay, but again, that's probably one of the most common things that happen. Actually, the most common thing that happens is that domain one gets sucked in and is not documented where it came from. Then we basically have sort of domain-specific collections where we suck up all these different things into one place and we put those matches. It's all in one place. We provide a service for it. Then we basically have aggregators who are pulling in data from multiple domains and downstream users may reuse a subset. They may say, okay, you've provided a curated library of vocabularies, I'm going to use these too. I mean, that sort of stuff is, again, fairly common. So there's probably other patterns. In terms of places to watch, in terms of who's doing a lot of stuff, I mentioned the European databases and the Publication Office of the European Union and SEMIC. I can't remember what it stands for again. Semantic. Anyway, basically, there's a mob who do things, publish things like DCAT AP and that sort of stuff. There is a lot of stuff happening there. We're currently working on multiple projects. I'm interested in other people's view on where else we should be looking for drivers. Okay, so is Vocabulary Federation a solved problem? No, not really. No one can really identify the standards. We don't see it in design of systems. We don't see people having the skills to do it. We don't see procurement requiring federatable vocabularies. We don't see the infrastructures that do very good jobs of federated vocabularies emerging ubiquitously. We see a few little examples like AgriVoc and Onto-Portal Alliance and so forth. And we've seen a few APIs, like we've been using SysVoc, that was generated in the past. No, it's an ad hoc specification. It doesn't exist as a standard. Nick Carr did some work on an open API SCOS stuff, which kind of interested in. There's an ISO standard somewhere for handling all the editing metadata, editing provenance. We've got the workshop in Brisbane coming up, which again is evidence that it isn't a solved problem. And I'm glad to hear it's submitted and accepted. That's fantastic. The OGC is about to release a call for participation around federated vocabularies, partly because I briefed my boss on the potential of this workshop, and I've written a little bit of an internal white paper about why it's a geographical problem and why we should consider taking a lead. And it's been acted upon, and there will be a call for participation around vocabulary federation capabilities to look at exploring these things. And hopefully, we want to move these things out of the domain and technology flavored implementations to actually having published standards for these things. The concepts are being presented at the OGC member meeting in Mexico next week, which I won't be at, so I won't have a tequila hangover. But yeah, there's something to look out for. I'll share it with the group as soon as anything goes public. The EU databases, absolutely, we're expecting to do stuff, but in the various projects we're doing, we're starting to look at publishing profiles and vocabulary bindings and so forth. And we try to inject this stuff into various EU databases work. There's the RDA workshop coming up. So it's a SciDataCon is the event. RDA is the organizing framework. And let's talk about it. And in particular, I'd like to talk about who might drive the usage use cases. We've got ARDC doing an excellent job of driving governance and supply of vocabularies, but we've got less sophistication in the next tier in terms of driving use cases. And just to sort of wrap up, one way of looking at these various different profiles is they're actually operating for different users. Very, very low level or very common foundation models and profiles like observations and measurements of, you can think of it as a profile of features. It's all about very general software and tools and common skills. Then you basically have specific patterns which can be implemented in software like the 3D Cadastral model. And then you have the profiles which are common and allow you to do interoperation between at the infrastructure level. All my applications will work with all your applications at some level. And that's basically the peers. And then individual applications will say, okay, here's how I talk to other applications in a way which is constrained. It's going to run on this infrastructure. It uses these basic standards, etc. So there's a bit of a hierarchy there. But again, wanted to leave with that because it's not a one size fits all. You need to understand what the reuse patterns are in terms of who the target audience is. Is it standards writers? Is it software developers? Is it infrastructure builders? Is it end data users? Is it data acquisition designers? Who are the stakeholders? And they have slightly different needs, and it needs to be unpacked. And there isn't a formal model that we're all using here. But if we can be transparent about the references, then we'll be able to maximize the reuse of the skills and the tools. So this is where I believe we need to focus. It's in this, what are the intermediaries going to do to help applications use standards effectively? And hopefully the case study I showed you, showing how the standards reuse gets leveraged by this inherited rules, unit testing, and the productivity it improves, will inspire you to think further about how we break the problem down and attack it. So I'll leave it there and take questions.